Okay, so now that you've learned the basics of C++, we're going to start with looking at different ways of organizing your programs. Organization is important for your programs because that makes them easier to follow and hence easier to debug and for other people to look at, debug, and improve. So this lesson is all about functions, which if you haven't picked up already is this right here, and actually main itself is a function too. But we're going to look at how we can use different functions and what the syntax is. So when you have a program with multiple functions, the computer will go through and do everything on the global scope. So anything that isn't in a function like this or this, and then it will skip this and go to find main. So when it gets to main, it'll start executing main. But if we want to use this function, we have to call it within main or another function, depending on where the execution is. So here we say the sum is, and then we call the addition function. And when we do that, what we're doing is we're passing it the variables x and y, which was entered by the user previously. And when we pass those variables, we're not actually giving the function the variable, we're giving it the contents of the variable. So it's basically like copy-paste. We copy the contents of x, and we paste it into A, and we copy the contents of Y, and we paste it into B. So any changes that are made in the function do not carry over into wherever the function was called from. So that would be whatever x equals to there. When you write parameters, like we did up here, they do not have to have the same names as what they were written down here. That would be silly, in case you had different variables you need to call the function from. So you can call them whatever you want, but just make sure that they have reasonable names, not like something that doesn't make sense, like turtles. So when it does that, these are actually already declared, so they don't need to be declared again. You can just start using them straight off the bat. So this function is addition, so it's actually really not that complex, so we don't need extra code. Functions can have as much code as you need to have in them. So in this case, we already get to the return keyword here. And we already know this keyword from main. In main, it causes the program to quit. But here, it only causes the function to end. And it has another function, that we don't really see with the return keyword in main. What it does is that it will take whatever value is after the return keyword and cause whatever function is evaluating it down here. It will cause this function, this call right here, to evaluate to whatever is in the return keyword. So in this case, it'll take these, it'll add it, and then whatever it returns, it will evaluate to here. So say we built it. It's taking forever. Okay, and we run it. Okay, so it asks us to enter two numbers, so we'll enter 7 and 4. So if it works, it'll come out as 11. It says the sum is 11. So that's a basic usage of functions. So you probably have noticed that there is a data type declaration here. And what this is this is the return type of the function. So basically, whatever this is has to match whatever this is. So because these are ints and we're adding them, it will come out as an int. But if you wanted to return like a char or a string, in this case, say you had a string, then it would have to be, then you'd have to say the function was a string type. And functions could be whatever data types you have access to. So it could be an int, a char, a bool, a string, or even, as you learn later, any data types that you create. So those are all available to you. And there's also one more return type that's available to you that you won't see used in many other contexts. And that is void. And what void does is effectively removes the need for a return statement. But what you're telling is that I'm creating a function that doesn't return anything. And this is useful if you just need the function to execute some code, but you don't need the value, or you don't need anything calculated to appear in whatever you're calling it from. So let's just say we have my function print something. If I can type. And that's all you need. You don't need anything more. Because it's not expecting a return statement. So it'll just execute this code, and then when it reaches the end of the function, it'll stop. There are uses for the return keyword and void functions. The only time you would use the return keyword is, say, if you needed the function to quit prematurely before it reaches the end. So say some condition prevents your function from executing properly. Then you would say within an if statement with that condition, and then you would just give it the return keyword without anything to return. That will just make the function quit. But you can only do this in void functions. Your compiler won't let you compile it if you just say return in something up here. So, also, when you have functions that don't have any parameters, like my function above, when you call it, you still need to give it the parentheses, even though there's nothing to pass to it. That's just telling the computer that I'm calling this function, not using it for some other purpose. So, when you're trying to call the function, you need to make sure you're using the parentheses. So a couple other things. When you're writing functions, the functions need to appear in some way before main. So any function that you write should appear before main. The code itself doesn't necessarily have to appear before main, but if you're going to do that, say we want void to go after. So say we had void appear down here. You won't be able to use that unless you do something called prototyping first. And that is basically to write out the first line of the function up here. So we'd say void my function. No parameters. And then you have to make sure you have a semicolon after that. That's the only time you would need that. And that's basically just saying I'm declaring a function. But in this case it's known as prototyping. So now that we've done that, the compiler knows that there is a function, my function, and then it will find this code and execute it. And actually, probably a better example to do this. So we had everything after that. In this case, you need to prototype addition too. And you do need to give it whatever. You do need to say the variables as well. You just need, actually, really it only needs the data type. You can give it the variable names too, but this would work too, because the variable names are only necessary in the function in the actual function where it's written. So, although for most purposes you probably should, especially later when we start writing classes, you should be putting the names of the variables in the prototypes. So, before I finish, we'll talk about the return statement in main has a very special purpose. It is actually returning whatever you pass it, except it's returning it to the computer, to the processor of whatever it's returning it to the OS. And this number has meaning. A 0 effectively means that my program quit without a hitch. It went perfectly. And then usually a 1 means that there were errors, like I quit because something bad happened. So, and the OS, depending on how it's set up, may or may not take action on that. But there are various uses for that, and it's good for debugging. If you remember back to the beginning of the video, one thing I forgot to mention is that when we passed the variables to the function, it was a copy-paste, so copy. But if you actually needed the function to change stuff and then have that appear in whatever you called it from, then what we do is we do something called passing it by reference. You would add an ampersand after the type definition, and that would make it anytime it's called. Instead, it will take the actual variable and change it. So that's functions. Up next is arrays.